Hello everybody. In the previous chapter of module 1, we discussed what is a data structure. We reviewed concept on arrays, functions. We discussed the three parts of a function, pass by value and pass by reference. And finally, we discussed concepts on structures and unions. In the second chapter of module 1, we will mainly focus on array operations. In chapter 2 of array operations, we will discuss the following topics: traversing, inserting, deleting, searching, sorting, multidimensional arrays, polynomials and sparse matrices. So what is array traversal? Array traversal is a process of accessing each element of an array. What are the different operations that require traversing? We have operations such as insertion, deletion, updating an array, also finding the sum of n elements of an array, so on. So all these operations require us to access each element of an array. So this is called as array traversal. Let's look at an algorithm for array traversal. Consider an array which consists of 5 elements. Let the 5 elements be 5, 2, 1, 0 and 10. The index values of the array is 0, 1, 2, 3 and 4. Let the name of the array be LA. Now array traversing is nothing but trying to access each element of an array. So 0 is the lower bound of the array represented by LB and 4 is the upper bound of the array represented by UB. Let's assign LB, that is the lower bound of the array, to a variable called as K. So with this understanding, let's look at the algorithm. LA is an array with lower bound LB and upper bound UB. Algorithm applies an operation called process to each element of LA. So process can be any operation which accesses the array elements. We know that algorithm is a step-by-step method of solving a problem. So whenever we write algorithm, we follow steps. So the first step of an algorithm of array traversing is initialize counter. Set k equal to LB. In an algorithm, whenever we write any comments have to be written within the rectangular brackets, and then it must be followed by the instructions. So here the instruction is set k equal to LB. Colon equal to means it is assignment operator. So whenever we write assignment operator in an algorithm, we write colon and equal to. So after initializing the lower bound to a variable k, step 2, repeat step 3 and 4 while k is less than equal to upper bound. The value of k is 0 and upper bound value is 4. Step 3, visit element. So apply process to LA of k. So for each element of the array, we have to apply some process. Step 4, increment counter. Set k equal to k plus 1. So as long as the value of k is less than or equal to the upper bound value, we have to apply some process to each element of the array and keep incrementing the value of k. When the value of k becomes greater than the upper bound value, that is when the k value becomes 5 is greater than the upper bound value 4, then the algorithm terminates. So step 5, exit. The same algorithm can be rewritten for a for loop. LA is an array with lower bound LB and upper bound UB. Step 1, repeat for k equal to LB to UB. So this statement in a for loop is nothing but for k equal to LB, k is less than or equal to upper bound, k plus plus. So these three lines can now be written by using a single statement as shown in step 1. Step 2, visit element. Apply process to LA of k, and step 3, exit. So this is an alternate method of writing an algorithm for array traversal. Insertion and deletion operation. For insertion, we need to first expand the given array, then identify the position to insert the element. Next, adjust the remaining elements so as to insert the new element, and finally insert the element. Consider the example shown here. Suppose if an element has to be inserted at index position 4, then the current value, which is Wagner, has to be first moved to the next position, that is index value 5, and once the space has been made available at index position 4, then the new element can be inserted. Thus we can say that during an insertion operation, the size of the array increases. For deletion, identify the position of the element to be deleted, then delete the element. Adjust the remaining elements to fill the empty space in an array. Thus, during a deletion operation, the size of the array decreases. In our first lab program, we have demonstrated how an insert operation works on an array. Now, let's look at how to write an algorithm for the same insert operation. Whenever we write an algorithm, we need to give a name to the algorithm. So, the name given here is insert, followed by the parameters which will be used for the algorithm. So, here the parameters used are LA, N, K and item. Next, we need to define what does each of these parameter means. LA is an array with n elements. K is the index of insertion of item. In the lab program, the variable K was replaced by the variable position. Now let's look at the algorithm. This is the same algorithm which was implemented in the lab program. Step 1, initialize counter. Set I equal to n. As discussed previously, the comments in an algorithm are written within the rectangular brackets, and assignment operator in an algorithm is written as colon followed by equal to symbol. Step 2, repeat steps 3 and 4 while I is greater than or equal to k. Step 3, step 4, step 5 and step 6 are all used to insert an element at a particular position in the array, and step 7 is exit. Here is an algorithm for delete operation. The name of the algorithm is delete followed by the parameters LA, N, K and item, where LA is an array consisting of n elements, K is the index of deletion. As you can see, comments are optional, so wherever necessary, comments can be made used in an algorithm. But whenever comments are used, it has to be written within the rectangular brackets.